Good morning, dear students. How are you all? I hope you all will be fit and fine. So today I am going to discuss a very important topic, and this topic is from the chapter Atomic Structure. So in the atomic structure chapter, this is probably the most important topic because frequently you are going to get questions from this. Sometime you get numerical from this topic, sometime you are going to get the theoretical questions from this one, which are also the application based. So in this, I'm just going to explain you the topic only, and the name of the topic is the Bohr's atomic model. So let me just write Bohr's atomic model. All right. So in this Bohr's atomic model, we are going to see what are the important postulates. Now this topic, Bohr's atomic model, that becomes important because it helps us in overcome the drawbacks of the Rutherford atomic model. If you remember, what was the drawback of Rutherford atomic model? So the drawback of Rutherford atomic model was that, according to Rutherford, that electron was revolving around the nucleus. It was not having anything fixed. So actually electron is being a charged particle. If the charged particle is rotating around another charged particle, that is going to, means that charged particle, that is electron, is going to produce continuously electrical and magnetic field. And if it produces electrical and magnetic field, then what will happen is energy will decrease, and ultimately what will happen? It will show a spiral motion and fall into the nucleus, and atom will burst. And technically, if atom burst, then nothing would have existed in the nature. But actually we are existing, and all the things surrounding us, they are also existing. That means that doesn't happen. So that thing could not be explained by the Rutherford atomic model. So in order to explain this thing, why it is not happening, we are having the Bohr's atomic model. So let's start with the first postulate of the Bohr's atomic model. So according to the first postulate of the Bohr's atomic model, what it says? According to the Bohr's says that electron in an atom is revolving in the circular path around the nucleus. What it means? Let me just write it down. Electrons in an atom are revolving in the circular path. So electrons are revolving in atom in a circular path around the nucleus. So what happens when electron is revolving in the circular path around the nucleus? It means that there we have the nucleus of the atom. All right, this yellow one is nucleus of the atom, and in this, around this nucleus of the atom, we are having certain circular path. So like this first circular path I am making, then we are going to have the second circular path, then we are going to have the third circular path, and so on. We have the many circular paths in the atom, and basically in this circular path of the atom, or electron is present. So electron would be somewhere into this orbit, or in this orbit, or in this orbit. So that is what is the first postulate. What is the first postulate? Electron in an atom are revolving in a circular path around the nucleus. So Bohrs actually gave this circular path named as orbit or stationary state. Now you must be thinking, okay sir, orbit is, we are understanding that is orbit because electron, this is when it's circular and electron is revolving around it. But why we are calling it a stationary state? Now the reason behind calling it a stationary state is also there. Why we are calling it a stationary state? Because these circular paths are having fixed value of the certain things. What are those things? Fixed value of certain thing, that means that these are having fixed value of energy. All right, they are having fixed value of radius. They are going to have the fixed value of momentum. So these circular path are called orbit or the stationary state. We are calling them stationary state. Bohrs call them stationary state. Why he called? Because these circular paths are going to have the fixed energy of things like energy, radius, and the momentum. All right. So that is why we gave them name stationary state, or we call them orbit. Sometimes we also call them energy levels. Sometimes we also call them shells. So different names we are having for this circular path. So here we are going to have the first orbit. The first orbit is the one which is closest to the nucleus. So you can see that this one is the nucleus, and the closest circular path around the nucleus is this one. So we are going to say this is going to be our first orbit. Then the orbit which is at the second closest to the nucleus, then we are going to call it the second orbit or the second energy level. Likewise, we are going to call it third orbit or the third energy level, and like that. So when electron is revolving into this circular path, these circular paths are going to have the fixed value of energy, fixed value of radius, and fixed value of momentum. That is why we are also calling them the stationary state. Now when we talk about the energy, Bohrs also make a derivation for the calculation of the energy of the electron, and the energy of the electron can be simply calculated by using the formula minus 13.6 into z square upon n square. So with the help of this formula, we can calculate the energy of any orbit. Like if I want to calculate the energy of first orbit, I have to use this formula. By using this formula, I'm going to get energy in terms of the electron volt. A unit of the energy is going to be electron volt. And what are n and z here? Z is representing simply what it is representing. It is representing the atomic number of the element. What is n here, sir? N is representing the number of orbit. As I said, number of orbit. That means if we are talking about this circular path which is just close to the nucleus, that means value of n is going to be 1 here, because this is going to be your first orbit. If you are talking about this one, then the value of n is going to be second orbit. Value of n is going to be 2. If you are talking about this one, then value of n is going to be 3, like that. So z is representing atomic number of the element, and n is representing number of orbit, which number orbit we are using. So we can calculate energy of any orbit by using this formula. We are going to get energy in terms of the electron volt. If you want to calculate radius, so radius of this orbit or the circular path, that is center distance from the center to the periphery of the circle, we can calculate by using the formula 0.529 into n square by z. Okay, if we are using this formula, we are going to get radius in terms of the angstrom, and you know angstrom is what? 1 meter is equal to how much? That is equal to 10 to the power minus 1 angstrom is equal to how much? That is equal to 10 to the power minus 10 meter. So that is the unit of the radius. We can, if we are using this formula, you are going to get the radius in terms of the angstrom. And there is one more term which is momentum. So here we are basically going to talk about the angular momentum of the electron. All right, so that we are going to see the later on, angular momentum of the electron. So according to the first postulate about Bohr's atomic model, thing is very simple, that electron is revolving in a circular path around the nucleus, and the name of this circular path is either orbit, or you call it a stationary state. If you want, you can call it shell also. If you want, you can call it energy level also. All right, so why we are calling them a stationary state? We are calling them a stationary state because they are going to have the fixed value of things like energy, radius, and momentum. That is the angular momentum. How we calculate the energies? Energy can be simply calculated in terms of the electron volt by using the formula minus 13.6 z square by n square. Radius, if you want to calculate, you can get it in terms of minus in terms of 0.529 into n square by z in angstrom. Suppose if I ask you what questions, what numericals you may get from here, they will be asking you to calculate the energy. They will be asking you to calculate energy of first shell, second shell, or the third shell of the hydrogen atom. So if you want to calculate this one, just simply put value into this formula. What we are going to have? For the first shell, we are going to have 13.6. How much? Z is how much? For the hydrogen, hydrogen is having atomic number 1. So value of Z will be 1 square. Value of N, since we are talking about the first energy level, so value of N will be equal to much? 1. How much will be energy? Energy is going to be your minus 13.6, minus 13.6 electron volt. So likewise, if you want to calculate energy for the second energy level, what it will be? It will be minus 13.6 into value of Z is going to be 1 square. Again, value of N is going to be 2 square. If you finally calculate, what value you are going to get? You are going to get value minus 3.4 electron volt. Likewise, for the third energy level, how much you are going to get? For third energy level, you are going to get energy minus 1.5 electron volt. Likewise, they will ask you to calculate the energy of the different energy level, or sometimes they ask you to calculate the ratio of the energy of different energy level. This kind of the numerical question you are going to get from here. Likewise, if you want to calculate the radius of radius of any orbit, you can calculate by using the formula 0.529 into n square by z. Simply put values into this one. Suppose again here I am asking you to calculate energy, calculate the radius of first, second and third. Just we have calculated here, so we can also calculate radius of first, second and third orbit of the hydrogen atom. What we will do? Simply put this formula 0.529. Okay, for hydrogen atom, if we are talking about the radius of orbit of the hydrogen atom. So what we will do? We will simply put here value of n is equal to 1, value of n is equal to 1, make it square upon z. Z is how much? Z is equal to 1. Again, what will be value? 0.529 angstrom. That will be the value of first one. Likewise, if you calculate for the second one, what it is going to be? 0.529 into value of n this time is going to be 2, make square of the 2 upon z. What you are going to get? You are going to get value 2.116 angstrom, and likewise 4 angstrom something you are going to get for the third energy level. So they may ask you question from the postulate itself. Which postulate is correct, which postulate is wrong. They may ask you to calculate the energies level, they may ask you to calculate the ratios of the energy. That kind of the question you are basically going to get from the Bohr's atomic model and from the first postulate. Now if you have noted down this first postulate, let's move on to the second postulates of the Bohr's atomic model. So in the second postulate of Bohr's atomic model, what we are having? Second postulate of Bohr's atomic model simply tells us, what it tells us, electron do not change its energy by itself. What it means? It means that if any electron in the atom is present in the first energy level, then that electron is going to be in first energy level forever. If any electron is present in the first energy level, then this electron is going to be in the first energy level, they're going to stay in the first energy level forever, until unless we are going to make any change in the energy of this electron. Let me just write it down. P2 says that electron present in energy level, energy level do not change its energy, and that is the important point. Now if electron is not changing its energy, then what we can do? We can change the energy of the electron until energy is added or removed from electron. So there will be simply, what is the meaning of second postulate? Meaning of second postulate is very simple. Electron's energy is going to remain constant. Its energy is not going to change by itself. If we are providing any energy to the electron, then definitely energy of the electron is going to increase. If we are going to withdraw energy from the electron, if you are providing energy, then energy is going to increase. If you are withdrawing energy from the electron, then its energy is going to decrease. So just we have computed what is the energy of first energy level. So energy of first energy level, thus we computed the energy comes out to be minus 13.6 electron volt. For the second energy level we had energy how much? 3.4 electron volt. For the third energy level, how much energy we had? We had minus 1.5 electron volt. So you can see that as we are moving away from the nucleus, energy of the energy levels, or energy of the stationary state, or energy of the orbit, that is continuously going to increase. So suppose if my electron is present into this first energy level, and I want to send this electron from first energy level to the second energy level, then what I need to do? I need to provide extra energy. I need to provide extra energy to this electron. If I will provide extra energy by making a suitable wavelength radiation falling onto the surface of this electron, then its energy is going to increase. And once energy of this electron is going to increase, then if it reaches up to minus 3.4 electron volt, then it will come to the second energy level. If its energy is increasing up to 1.5 electron volt, if energy becomes 1.5 electron volt, then it will come to the basically this third energy level. So likewise, important thing is what? Important thing here is transition of electron. Transition of electron. What second postulate talks about? This second postulate talks about the transition of electron. It wants to say that electron do not undergo transition by itself. Transition of electron, that means change in the energy level. Change in energy level of electron. Electron is not going to change its energy level by itself. But what if you are providing energy to it? What if you are withdrawing energy from it? Then what will happen is the energy will change, and if energy of the electron changes, then it will change its energy level. So change in the energy level of electron, or change in the orbit of the electron, that we are basically calling transition of the electron. So what happens if we are adding on addition of energy? If we are adding energy to the electron, then electron will move to the higher energy level. That means on increasing energy, on addition of the energy, electron goes to the higher energy level. That means it will move from n equal to 1 to n equal to 2. That is how we show the transition of electron. We just write down the two states. That is the initial state and that is the final state. Alright, and we make an arrow like this. So this arrow is signifying here. See, the head of this arrow is representing the final state. This is the final state of the electron, and n1, the tail of this arrow, is representing the initial state of the electron. So if we want to change the energy level of electron, then we need to change the energy of electron, and accordingly it will undergo transition. On addition of the energy, electron goes to the higher energy level. On removal of energy, if you are removing the energy, on removal of energy, so this one is going to, suppose if your electron is having energy, how much? It is going to have energy here 3.4 electron volt. Now what if this electron is emitting energy? If this electron is emitting energy, expelling energy, then its energy is going to decrease, and this electron is going to move from this third energy level to the second energy level to the first energy level. So what is happening here? Electron is moving from higher energy level to lower energy level. So we will write here, on removal of energy, electron moves in lower energy level. All right. So the second postulate, first postulate basically talks about there is a fixed value of the things, and they are called as stationary states that can be computed. And the second postulate talks about these energy states are going to have the fixed value, and they are not going to change by themselves. If they are not going to change by themselves, then the transition of electron, that means change in the energy level of electron, will not occur. But if you are providing any extra energy to the electron, then energy will change and accordingly electron will move to the higher energy level. So that is represented by this initial energy level to the final energy level. On removal of energy, what will happen? Electron will move into the lower energy level, and that will again be represented by, here electron was moving from initial energy level to final energy level. So initial energy level was N2 and final energy level was N1. So second postulate basically talks about the transition of electron into the Bohr's atomic model. So I hope you would have understood to this postulate. Now let's move on to the third postulate of the Bohr's model. So the third postulate of the Bohr's atomic model. What is the third postulate? This third postulate actually talk about origin of the atomic spectra. Now you must be thinking, origin of atomic spectra, we have here somewhere atomic spectra in this chapter itself. Atomic spectra you would have studied. In that we were talking about the hydrogen atom. That hydrogen atom was emitting some radiation. So why that hydrogen atom or any particle is emitting radiation? So this third postulate is talking about the concept of emission of the radiation. So what it says? It says that the wavelength of radiation in spectrum, or wavelength of radiation depends on difference between energy of two energy levels. What it means? It simply means that if we want to calculate wavelength of radiation which is emitted during the spectrum, so that can be calculated. And how its value is going to change? So its value is going to change depending on the transition, from which energy level electron is undergoing transition. So on the basis of that, we can calculate the wavelength of radiation. What is formula for that, sir? How we are going to calculate? Simply we will apply formula. Energy of radiation is how much? So we are having a formula. We are having formula for this, hc upon lambda. All right. That is basic formula that we are using from the Planck theory. Radiation, energy of radiation is hc upon lambda. Now, as according to this theory, this depends on what? This depends on the difference in the energy level. So what we will say, it depends on the difference in the energy level. So we'll simply write energy of final state minus energy of initial state. If we rearrange this one, what we are going to have? We are going to have formula 1 upon lambda, that is equal to what? That is equal to 1 upon hc. Here I am writing it E2 minus E1. All right. So that will be the simple formula. With the help of this formula, which is similar to that of the Rydberg formula, if we compute this energy in terms of the joules, then we are going to get the Rydberg formula for this. So in this formula, what we have the lambda here. This lambda, what it is representing? Lambda is representing wavelength of radiation. Here h is what? H is your Planck constant. C is what? Here it is going to be C. C is what? C is the velocity of light, like that. So the third postulates talk about the origin of the atomic spectra. According to this, whatever wavelength of radiation is emitted, that wavelength can be calculated, and that wavelength is mainly going to depend on difference between the energy level, difference between the energy of two energy levels. How we calculate difference between the energy of two energy level? That is, we calculate it by final energy minus energy of the final state minus energy of the initial state. and we are having this formula hc upon lambda that we basically use to calculate the energy of any radiation. So we just use that formula and we derive another formula for the calculation of energy. Now this postulate also says, from the third postulate, what we can conclude, since we are having few fixed energy levels are present in an atom, like we are going to have E1 energy level. So we just computed E1 energy level for the hydrogen atom, that was minus 13.6. We computed energy for the second energy level, that was how much? That was minus 3.4. We calculated energy for the third energy level, so that was how much? That was 1.5. So what it means? It means that we are going to have the certain energy level, and the energy of this different energy level is different, and that is fixed. Now what happens, since we are having the fixed value of energy of different energy level, then difference between the energy of two energy level, that is delta E, is also going to be fixed. All right, if delta E is also going to be fixed, that means if we put into this formula, what we are having 1 upon lambda, 1 upon hc, 1 upon hc, and you are going to have delta E. So if delta is going to fix and h and c are the constant, then it means what? It means that the value of lambda are also going to be certain fixed values. So if the value of lambda is again going to be fixed, because a difference in the energy of the two energy level is fixed. Why it is fixed? Because every energy level is having fixed amount of energy. So if everything is going to fix, that means we are going to get few fixed wavelength of radiation. That is why when we get the spectrum of the hydrogen atom, we get splitted lines. We do not get the continuous spectrum, but we get the discontinuous spectrum, because this transition correspond to the certain fixed energy level values. So that is what is the third postulate. Third postulate says that wavelength of radiation which is emitted from the atom can be calculated, and that can be calculated by using this formula. All right, I hope this third postulate will be clear to you. Let's move on to the fourth and the final postulate of this. Fourth postulate simply says electron remains present only in those energy level which are having value of angular momentum, integral multiple of h upon 2 pi. That means what? Now see, we are having an electron, there is this atom, there is this orbit, we are having this circular orbit. In this circular orbit, our electron is revolving. From the center of the nucleus, we are having this distance r, means up to the periphery of the orbit we are having distance r. Now this electron is moving with some velocity v. So like the linear momentum which you study in physics, so same we are having the angular momentum. So angular momentum we can calculate. Angular momentum of the electron is equal to how much? Angular momentum of electron is equal to mvr, where m is the mass of electron, v is the velocity of electron, and r is the radius of that particular orbit. So what this third postulate says that there are infinite number of orbits are present. Obviously in atom there are so many orbits, but out of those so many orbits, in only in those orbit electron can be present. For those orbits, if value of angular momentum mvr is equal to how much, that is equal to nh upon 2 pi. All right, so that again means that this n is going to be the whole number integer. It can be 1 2 3 4 like that. It can have any whole number integer, it cannot be fractional. So it means what? It means the value of angular momentum is going to be changed by a fixed number. That means what can be the value of angular momentum? Value of angular momentum can be, for first energy level, h upon 2 pi. All right, for the second energy level, it can be like 2h upon 2 pi. So it will be what? It will be simply h upon pi, like that. So electron will present only in those stationary states or the orbits whose angular momentum changes according to this formula, where n is again your whole number integer 1 2 3 4 5, that is representing number of shell, different number of different energy level. So if their angular momentum comes out to be equal to this formula, then only in those orbits your electron can be present, otherwise electron won't be present. So this actually explain an important concept, that is quantization of angular momentum. Now what is mean by quantization? That means if any value is changing and that value is changing by a certain fixed number, then we call it quantization of that particular value. For example, we have one student, then we have two students, so we cannot have 1.5 student. So a student's number will increase one by each after every interval, student number will increase by 1 unit. So like this is going to be called quantization of the angular momentum, because it is going to increase by the fixed number. And the last thing about the Bohr's atomic model is that there are two types of the force. First one is the force of attraction. So the force of attraction, that is between the electron and the nucleus, and it can be calculated by simply Coulomb's law, K Q1 Q2 by R square. All right, K is what? K is going to be or dialectical constant. Q1 is charge onto the electron, Q2 is charge onto the proton, R is what? R is the distance between the electron and proton. So we are going to have the force of attraction between the nucleus and electron, and that is going to be the electrostatic force of attraction. So electrostatic force of attraction we are going to have in the atom, and that electrostatic force of attraction, that is also equal to force of repulsion. So we are having force of repulsion. So in any atom, we are having a force of attraction, we are having a force of repulsion. Force of attraction is electrostatic in nature, simply we can calculate it by Coulomb's law. And then we are having a force of repulsion. Then force of repulsion is what? That is mv square by r. So we are going to have this centrifugal force, that is basically your centrifugal force, that is representing force of repulsion, and that is representing electrostatic force of attraction. So every atom we are going to have these two forces, and these two forces are equal to each other and they act in opposite direction to each other, and that is how every atom exists in the stable form. So I hope guys this topic would have been clear to you. Bohr's atomic model. Just let me give a quick recap for this. What we are having, Bohr's atomic model help us in understanding, overcoming, help us to overcome from the drawback of Rutherford atomic model. How we overcome from the drawback of Rutherford atomic model? Simply from the first postulate itself. According to the first postulate, every energy level is having the fixed energy, so its energy can be computed by using the formula. Its a radius is going to be fixed, its a momentum is going to be fixed, all these are going to have the fixed value. The remains fixed until unless we are making any changes. So that is basically we are going to learn from the second concept. The values of things like momentum, energy level, radius of any orbit remains same. Means electron which is present in any orbit remains same, because they do not change by themselves. But if we are making any changes into them, then we are forcing electron to change its energy level. So change in the energy level of the electron, that is simply called the transition of electron. So the transition of electron again depends on what we are doing. If we are adding energy into the electron, then electron is going to move from lower energy level to higher energy level. If we are going to remove energy from the electron, that means what? That means electron is going to move from higher energy level to lower energy level. Whether it is absorbing energy or removing absorbing, electron is absorbing energy or electron is emitting energy, electron is simply going to undergo change in its energy level, and we call it transition of the electron. Now the third postulate is what? Third postulate simply is explaining us during the transition of the electron, certain wavelength of radiation either absorbed or certain wavelength of radiation either emitted. So the wavelength of emitted radiation or absorbed radiation can be simply calculated by using this formula, and the value of the wavelength is going to depend on the difference between the energy level, difference between the energy of the two energy level. Okay, since these energy levels are having the fixed value of energy, that means difference between the two energy levels, value of delta E between the two energy level, that is also going to be the certain fixed value. So if we put this into this formula, then we are going to have the certain fixed value of wavelength also. So that is why a spectrum of the hydrogen atom is shown as a discontinuous spectrum. It do not emit all the radiation, but it emits a value of certain particular wavelength because of the quantization nature of it. Then we are having a third postulate. What is fourth postulate? There are infinite number of energy level. In which energy level your electron will be present? Electron will only be present in those energy level. For them, in those energy level which are having value of angular momentum in terms of the integral multiple of h upon 2 pi, where n is simple whole number integer representing number of shells. If we put into this value, we get the different value of the angular momentum, and that is how we calculate that is how we decide in which energy level our electron will be present. Then the last in list, we are having a force of attraction and force of repulsion. Force of attraction is between the two charges, that is electrostatic in nature, that is the electron, Q1 is charge onto electron, that is charge onto the proton. Alright, and this case we are having a dielectric constant. Then we are having a force of repulsion. Force of repulsion is because of the centrifugal force. It is this due to the rotation of this electron. This electron will be move away from, means it will be directed away from the periphery of the center. So we are having a centrifugal force. Both forces are basically equal. That is why atoms are exist in a stable form. Alright, so I hope this will be clear to you. Thank you very much.